derivative to prove the maximum minimum parts for the questions. Okay, 17.1 homework.
This one if you don't do the first part, you can still do the second part, right?
Yes, of course. Yeah. Okay, exercise 17.18 C, F, 9, 8, 11, 12, 17. Today is Thursday. Would Monday be okay? 7, 8. Monday? You sure? No test?
Can.
You look like you're dying, you know. Look at Yuriko's face. You look like she's gonna kill me.
Actually, we end at 4 by teacher.
Yeah, but 17.1 due on Monday, okay?
Yeah.
Sorry, I cannot detect sarcasm very well. I only know how to express sarcasm, but I don't really detect it very well. So it's better to be honest.
What is skill?
Actually, we die already.
Yeah? So now we're going to 17.2. 17.2 is the best.
Yay!
Because the differentiation is the simplest.
Simple to you doesn't mean simple. Yeah, this is trivial, right?
Hey, if this one is not simple, I don't know what else is simple already.
1 plus 1 is simple, Joe.
This time, I cannot sense a character.
The derivative of exponential function is exactly the same thing. How can this not be simple? Right?
When you differentiate, why?
Life still needs to differentiate certain things. Okay? Still needs to be defined.
So wait, how does it become the same thing?
How does it become the same thing? I suggest that you go and pursue mathematics as a degree and then you will learn it more in courses.
Like even you bring down the power, right? Then minus 1.
Yes.
Do you pursue mathematics?
Yes, maths is my degree, but I hated calculus. Yes, I do pure mathematics. So you ask me algebra, numbers, I'm okay with that. But when it comes to calculus, when limits are involved, okay, it really made me reach my limits. Yes. Okay.
So what x equals to e?
X is equals to e. Cannot be much. E, then e is a number. Then you differentiate what? Right? E the power of e is only a constant. So that will end up to 0. Right? Okay.
Wait.
Very confused.
Wait, what?
Correct, right? He asked how to differentiate e to the power of e. E to the power of e isn't just a number. Correct? It's constant, right? So differentiate a constant will become 0. Okay? So let's look at try 8. Okay, x plus 1 times e to the power of x. So definitely our product rule will still hold. Okay, so if this is equals to y, keeping the left, differentiate e to the power of x remains the same. Then after that plus, keeping the right, differentiate the left.
You're so me right now.
Okay?
This how little logarithm come out, right?
Our logarithm, I'll admit is a bit difficult.
Just a bit only. Never mind,
Let's prepare the I can do it.
Very good, I like your optimism. Okay? So
factorize.
You can factorize it or you leave it in this way, it's fine. Okay?
That's very nice about x plus 2.
Yeah.
So can explain to us why
Sorry, I didn't prepare that part of lesson, so I don't know how to answer the question. I'll be very honest. Why is it? I go and read 10. But I don't know whether you have the concepts to understand.
Yes.
Limits, you know.
So what are they?
Limits, there's like certain epsilon. That's all I remember. Limits is written this way.
Oh wait, I see.
So as x approaches 0 for a certain function, Yeah, then after there's some theorems going on, then after that it will tell you that it's going to be cosine x. That's all I know. Something like that, if I'm not wrong. Okay? Yeah, it's in the textbook. Yeah. But I don't think your textbook tells you everything.
Yeah.
So there is another textbook that will tell you everything called Thomas Calculus. Yes.
How did that die?
Oh, this is 1 what, right? You grade 1 times e to the power x ma. So factorize e to the power x. That will be x plus 1 plus 1 ma. Right? So x plus 2. Okay? Then you understand my answer for part A? No? Why, Eddie?
I just got to the first part.
Okay. Okay, then after that, next one.
Right, left.
Okay, 2e to the power x over x. Right, so if this were to be equals to y, okay, keeping the bottom, differentiate the top minus the top, differentiate the bottom, and then x squared. So it's quotient rule. Okay, then you will get this. Right? Teacher, I noticed that you like to use product rule a lot. Please be very careful in the way you use your product rule. Okay. Because I was marking homework. Then all the product rule application is wrong. Yeah. So yes.
Yeah.
Okay. Okay, then after that, next one, part C, right? If I want to differentiate e to the power x minus 1 to the power 2, okay, so your power rule will also apply. Bring down the power, minus away 1, okay? Then after that, differentiate the inside. So differentiating inside still remains as e to the power x, minus 1 differentiate 0 already, okay? So therefore,
So 2ex stays as 2ex.
ex, you say as ex. You said 2ex, it stays as 2ex.
No, as in like previous one.
Oh,
The 2 is stay. The 2
yeah,
will stay.
because, so if you want to differentiate, okay, 2ex, okay, because keep this, differentiate the top, right? Differentiating this one, this is a constant one, right? Okay, so if you think about it, you want to apply product rule to two separate things, 2 and e to the power x, right? Okay, you can keep 2, then after differentiate e to the power x, that will be e to the power x. Plus, keeping the right, differentiate 2 itself will become 0. So therefore, the derivative of 2e to the power x is equals to 2e to the power x. Okay? So any constant times e to the power of x, as long as you want to differentiate it, it will remain as the same expression. Okay? And here you go. What's wrong? Are you following?
Maybe part of me knew it was you, so I asked you. Maybe part of
Okay, so for try it, we were looking at everything that involves e to the power of x. Now what if, okay, I want to differentiate things like e to the power of 2x plus 1. Okay, so therefore in this case, like how we have to differentiate the insides of the brackets, we will have to differentiate the powers as well. Okay, so how does this actually work? Right?
Let's go.
So the function remains the same as when it is being differentiated, but we need to differentiate the power itself, and that will be equal to the 2. So therefore, in this case, it will be 2e to the power of 2x plus 1. Okay, so chain rule, the way it applies, right, remains the same. You differentiate the function, then remember to differentiate the other parts of the function. Okay? First one, I don't know.
The 6, then on top of the tail thing.
Oh, the delta. Like that. This is a
Isn't
delta.
that a piano note? Isn't like a music note?
Small lah. It means very small, right?
It's a delta sign. Okay?
It looks like you're learning.
Let's look at part B.
Like just there. Okay, just go
Okay, so let's look at differentiating e to the power of square root x. Okay, so if you let this be y, you should know that e to the power of square root x is the same as e to the power of x to the power of half. Right? Okay, so therefore to differentiate this, okay, the exponential function remains the same, e to the power of x to the power of half. Okay, then after that, don't forget to differentiate x to the power of half itself. That will be half x to the power of negative half. Right? Okay, so therefore, e to the power of square root x over 2 square root x.
I'm learning.
Okay?
I finished it.
So then Charlie answer is half E, half B.
There's no Latin letter that represents that. It's not your Latin letter. Okay? And then after that, part C, right, we want to differentiate e to the power of negative x times cosine x. Right, what do you think will be the answer?
Complicated. E you make it you make it the over fraction first, right?
Oh, why you want to do that?
Oh wait.
Why can't you just put out
No,
rule?
so I see the e to the power negative x. Does it still says e to the power negative x?
No.
So make it negative first.
Okay, so how to differentiate e to the power of negative x?
Negative e to the power
E to the bracket. Stay.
Say the same, then the negative x?
Then the negative
Is it negative e to the power x?
Negative e to the power of negative x, right? Okay, so
E to the power.
keeping this, differentiate cosine negative sign, right? Then plus, you want to keep the right product rule, okay? Then we differentiate e to the power of negative x, that will be e to the power of negative x. Differentiating negative x, that will give you
Negative 1.
negative
No,
1.
what I was asking was e to the power negative x stays as e to the power negative x.
But then you still got the
Why
negative x to
though?
differentiate.
Why?
What do you mean why?
Why does it stay when there's a it's like that.
Just like why all these days when there is square root x, but then we still have to differentiate the powers. So I still differentiated the negative x and negative 1. Okay? So therefore in this case you will get negative e to the power negative x sine x minus away e to the power negative x sine x. You could choose to factorize it, so that would be sine x plus cosine x over negative e to the power of x. Huh? Okay, so I show you the steps. Negative e to the power negative x sine x plus cosine x. So you can express it into a fraction. Okay?
Why you got still the
Negative. Factorize
but the power below?
Oh, sorry.
Oh, so no.
No, sorry. Okay?
Is that a new metal water bottle?
Okay, let's look at exercise 17.2, question 3. Okay, for A, okay, we are given y is equals to e to the power of 3x times e to the power of x minus 1. What do you think would be the simpler way to do this differentiation?
You combine the power.
Okay, very good because you read the textbook instruction, you see.
The dot is it a multiplication?
Yes, the dot actually simply means that it's a multiplication,
Why
right?
What did you just work out?
这导宋哲这
Huh?
这与导宋哲。
It's been a year.
Okay, the dot represents a multiplication. Sometimes we will use dots to represent multiplication. Okay, there are many ways to represent multiplication, right? It's just a matter of symbols. Okay, no, it is actually a mathematical universal symbol. Okay, so to differentiate this, it will be easier if we combine it into a single base e first. Okay, or in fact in this particular question they did tell you to combine it into e to the power of something, okay, into a single base, right? Because when you combine it this way, then it's much easier. You need not do your product rule, although you can also. Okay, so for e to the power of 4x minus 1. Okay, then after that for 3 part B, alright, likewise we will combine it into a single base.
It's a ballpoint pen.
Which will be e to the power x plus 3. Then upon differentiation, what would the answer be?
So is it plus? Wait, never mind.
The one that, yeah, the third.
Just e to the power of x.
Okay, it will remain the same.